It's okay. Oh, okay, it
Hey,
works.
hey, everybody.
Hey, folks. You made it to the end. So this is the end. So
Yeah, thank you very much for coming. I know it's Saturday, end of the day, really tough. My name is George. I'm here with Dimitris.
and we're gonna talk to you about our experience with Quarkus those last 7+ years.
Yeah, so initially I think in the description of the CFP, it said 6 years, but now since we've applied, it's 7 now. Since as we talked about yesterday, it was released March 2019. So it's been 7 years now.
Okay, well, have the clicker. So Quarkus is not your typical Java framework because at its core, Quarkus is an optimizing framework for Java applications. That's what it does. It's a framework of frameworks, and we had to reinvent, essentially how you do Java, and that's the team that released Quarkus 7 years ago. It was in Switzerland. We had a meeting. The team is all over the world. It's not just these folks. There are many more.
Well, half these folks aren't even on in Red Hat IBM now.
Yeah. Um, and the big challenge we had was to solve the problem of Java in the cloud. So what was the problem? In the cloud, density matters. So how much space your containers take, how fast they start, and Java was not competitive in this space. You had the application servers that took a lot of space. You had the Spring Boot apps that were bloated. So we had to solve this some way, and the solution was really related to how many classes your application has. That was a constant problem. That was a big thing to solve, and the main idea behind Quarkus was how we could reduce the number of classes that make up an application. And in order to do so, we came up with an architecture where for every framework, there is an extension that understands the framework, let's say for Hibernate, and the extension at build time, it tries to, let's say, initialize the application as if it was running. And in doing so, we can throw away all the parts of the application that are not needed when it runs. So basically, we generate the bytecode that does the initialization sequence, and we put that in the jar file. So when the application runs, it knows exactly what to do. It's like you have the solution to the problem. You don't have to look for any of it, and then you can get rid a lot of initialization code. And it just happens that when we do that, and we also do the extra step of producing a native image, we can actually burn on the image the ready state of the app. We don't even have to initialize it. It's already in memory. So when you run it as a native image, it just starts. And that explains why Quarkus is unbeatable in terms of memory size, startup speed, and the reason why nobody will ever manage to have the same results unless you replicate this architecture and you build up the Quarkus ecosystem, which is now more than 800 extensions. So, starting from that, a lot of things came, like dev mode, library load, dev services, continuous testing. And this is because with all this pre-processing we do when we build up the application, we have a very intimate knowledge of what the application does, so we can do all sorts of things and optimizations. I like to say that Quarkus was intelligent before AI came in, but intelligent in a deterministic way. We know what your application does. So 7 years later, what we learned, what we could do different, or what worked, what didn't work. So
yeah, so obviously, like with anything, right? With anything complex, you're gonna never get everything right the first time. Like you start out with the best intentions. In this case, we started out with an idea that has proven to be very good over the years. But like we've made a lot of decisions that are questionable, and we'll talk about some of them now and what we've learned, and what hopefully like other folks who develop open source software can learn as well. Let's start with the absolute basics, right? So for anyone who has contributed to Quarkus, you will know, like when you go to GitHub and see Quarkus, it's a massive Maven project that at this point probably has like more than 1,000 Maven modules. Now, that has caused, over the course of the years, a lot of problems for people that are like casual contributors, right? So you come in, you want to check it out, you want to fix something, and it's not easy because it's not like 5 Maven modules, it's 1,000 plus. And even like when you try to import IntelliJ, sometimes it would like just blow up, right? Or VS Code probably doesn't even work, or at least it didn't last time I tried. So that has led to other tools being improved because of how big and how important, let's say, Quarkus is. So, for example, IntelliJ uses the Quarkus build as a benchmark for how fast they can index a very large Maven project, right? Yeah, because like they had us complaining, they had other people complaining. So yeah, they did something about it. IntelliJ is great.
Who's using IntelliJ?
So almost everybody.
You can thank Quarkus, yes.
Yeah. So yeah, challenging Fridays. Of course, hard for contributors, but and and also in this AI world, of course, it's potentially challenging for coding agents as well, right? Because we're talking about a huge module, but we're doing things to improve. So let's see what we've done. So fairly early, like I would say, like 2 years into the project, we realized that like when people come in and say, I want this extension and I'm willing to work on it, it wasn't a viable solution to say, sure, yeah, let's stick everything in the core repository because that's the easiest way to get started. We figured out that that's not going to work. We need some tooling to actually allow people to develop their Quarkus extensions, and us being out of the way of that happening, but them being able to take advantage of all the rest of the Quarkus tooling. So, for example, when you look on code.quarkus.io or the Quarkus CLI, you look up an extension, you want these community contributed extensions to be there. And that's essentially what the Quarkiverse is, right? It's technically it's a GitHub organization with multiple repositories that different people contribute to. But when you create it with our tooling, it configures CI/CD automatically. It sets up all the metadata, which is allowed for the tooling to work, the Quarkus tooling. And what the other amazing thing it does is that who here has actually tried to release anything to Maven Central? How easy was that? Yeah, it's horrible. Like the experience of deploying to Maven Central versus, for example, like doing an NPM publishing thing is like horrible, right? So we've taken all that pain out, and Quarkus, let's say CI takes care of all that. But we'll also talk about later that has very good implications in security, because now with all the supply chain attacks, this stuff has become very, very important, which is also why it's easy in your previous site to transfer ownership, because like owners now, like people come and go, you need a reliable way to be able to transfer ownership to someone that you trust, right? And not just like some state entity.
Yeah, and the Quarkus ecosystem is vast now, right?
Yeah, we're talking about thousands of extensions.
Yeah.
So
and many companies like collaborating, Microsoft, Amazon. So
yeah, so everybody like that is interested in their stuff working good on Quarkus doesn't have to have us like approve what they're doing, right? They just participate in this, then they release in their own life cycle, right?
But we do test everything together to make sure that.
That's part of what we're going to talk about that later. Okay. Yeah. So naming, like this is where we've got it very bad, right? We've done a horrible job over the years because like essentially like when Quarkus was started, reactive was a big thing back then. So we say like Quarkus is reactive to the core. So we're going to say, okay, let's start sticking reactive into everything, right? So for example, we have rest easy reactive, and then we also have like hibernate reactive, and then we had, let's say, reactive messaging. But this was done in a completely inconsistent manner. So for example, rest easy reactive, as the name would lead you to think that it's only for reactive, but no, it's not. Rest easy reactive can also be used for blocking, which means that the name is horrible. Reactive messaging, same thing. But on the flip side, like hibernate reactive is a good name because you have hibernate ORM for the blocking stuff, and you have hibernate reactive for only the reactive stuff. So we've caused like a lot of people a lot of confusion over the years with this horrible naming. or sometimes like calling stuff micro profile something or like small rise something. We've done a very terrible job, but now we've tried to improve it. So now we're calling it Quarkus REST instead of reactive REST reactive, because that's what it is. It's a REST implementation. We call it Quarkus messaging instead of reactive messaging. It's good. It's clean. And to be honest, we learned the hard way that like Spring has done a very good job at this, right? They have consistent naming with everything, and people just get what the project is about.
Yeah. Well, I mean, at the core of it was that in Quarkus we have so many different projects, and we actually have the implementation of the projects,
Yeah.
not thin layers over other people's stuff, right?
So that's the other good thing. So it's good and bad, because with Quarkus, you had a lot of people that were super excited from the beginning, super capable, came up and did their own thing with minimal supervision, right? And then they release stuff and they have to give it a name, and they give it a horrible name, and that's fine, right? Because if you try to control everything from the top, then you're going to stifle innovation. So anyway, we enable innovation, but at the cost of like bad naming, right?
Yeah. A few things about our build time tooling, which is like let's say the secret sauce for Quarkus. There's a thing called Yandex, which is a very fast and efficient annotation processor. Because imagine all the libraries that do stuff now, they have to read annotations over and over again. So in Quarkus, we read everything once, we index it, and then it's very easily accessible and fast for any extension to query and find out, okay, where are you using this? Tell me all the classes that are annotated by this, all the fields, etc.
So, and we should also say that this existed before Quarkus, right?
It came from Wildfly.
From Wildfly, yeah, exactly. So Wildfly had identified some of these problems and put in place things like Yandex, which like Quarkus would not be what it is without like this layer.
Yeah,
right?
Because let's say half or a third of the Quarkus team comes from the JBoss team, right? Then another very nice thing was Gizmo. Do tons of bytecode generation, and it's really hard if you use ASM.
Who's generated bytecode or transformed bytecode with ASM? Lucky for you, you haven't done it. Good.
You have to be a framework maker, but yeah, Gizmo
it's
offers
a
much nicer, higher level API to do this thing, and it can abstract the backend, so it supports class file API for So yeah.
Yeah, essentially, it's one of the building blocks that we used in Quarkus, like to generate bytecode, that enabled a lot of people to be able to do a lot of cool things that we did not foresee in the beginning, right? So it was a very good choice.
So what about all these build items, build steps?
So yeah, so this is like basically for extension authors, but essentially what it means is that when Quarkus was built, like the lower level stuff, it doesn't follow like a spaghetti architecture where everything extension like plugs into wherever they want. Like so you ask somebody, "Oh, give me this, open up this method, I'll call it whatever." So that's not how it's done. There is a very, very specific way that extensions communicate to each other. Essentially, you can think of it as like
message passing.
Yeah, so it's essentially some like build items are messages, and then you have consumers of those messages that they consume something and produce something else, right? And that's a very good way of decoupling extensions from each other, right? So obviously some things are very, very core and everything else depends on it, but you don't want, for example, like Hibernate to depend on like gRPC, right? That makes no sense. So when you have this decoupled and have like a very nice interface of how these communicate with the core and then and consume and produce things, you get a very good decoupling. Now, the idea is awesome. Sometimes we've taken it too far in terms of like what this system was built and not built to do. But that happens, right? When you have a lot of people that are very excited, want to get stuff out, sometimes they bend the rules. So we occasionally have to like look back and say, no, this isn't good. We're gonna have to deprecate this, remove this, right? So that's all good. Yeah.
Build tools. Well, a lot of the magic of Quarkus is done at build time. So obviously we had to write our own plugins for Maven, and Gradle, kind of, but we're not Gradle experts.
Yeah, that's the thing. Like for the people that came from Red Hat, like almost everybody knows Maven, and some people know Maven extremely well, right? With the result being that like we design things in a very Maven specific way. So our Maven integration is amazing, and we help Maven improve as well, right? Like we tell the Maven team like we need this, and they go ahead and do it. But the flip side is that we had very little Gradle experience 7 years ago. We continue to have very little Gradle experience.
Maybe you can ask who uses Gradle. Yeah, there are a few. So.
Yeah. So yeah, for our Gradle support is definitely not where our Maven support is. The good thing is though, because like Quarkus has become important, we have people from the Gradle team helping us out and like showing us the proper way. Because Gradle, like, amazing tool, but it moves very fast, and there are like 5 different ways to do every different thing. So they come in and help us like no, you're not supposed to do it like that. Do it like this because you're gonna have these other side effects, right? This is a new one, right? Build reproducibility. So in various scenarios, you always want, like when you're doing like an MVM package or a Gradle build, you want the generated jar to be like exactly the same. Like you give it to a diff tool and you want it to be the same thing. This is good for like build caching, but it's also good for like auditing and things like that. Now, this is a very hard problem because, like Dimitris said, we do a lot of bytecode generation. We also do bytecode manipulation. And depending on, let's say, like when you generate a class, right? When you want it to be reproducible, you have to have a deterministic way. Like every field you generate has to be like specific. Like first I generate this, and then this, then this. Then same for the methods, and also the implementation of each method. So this is very hard. It's work in progress. The issue was probably opened like 6 years ago by people. We have been chipping away at it. So it should hopefully maybe sometime this year it will be done. Yeah, so our vision for Native, like Dimitris said earlier, right? Quarkus wasn't, when Quarkus was built, we didn't have GraalVM native image as like the first target in mind. We had an architecture in mind. It just so happened that this architecture lends itself extremely well to producing a very, very good and compact native binary with GraalVM. And how we do that is like we generate a optimized jar, like for the JVM. Then we pass that to the native image tool, GraalVM, with a bunch of flags and a bunch of configuration that you would never want to write on your own. So Quarkus does that for you. Then that resulting application is started up to a very specific point, right? So that's what the native snapshotting is. So you essentially, for each class that GraalVM knows about, it does a class 4 name, like, and loads the static initializer, the static block of each class, right? And whatever is loaded into the Java heap as a result of that class initialization becomes part of the native image. And that means that when it runs, a whole bunch of stuff has already been done, and it doesn't need to be done again, and it runs very, very fast. Now, if we go to the next slide, what we're saying here is that we took a very, let's say, all or nothing approach, and we said like everything on the class path has to be statically initialized at build time, right? No exceptions. This is what we're going to do. Now, we've heard a lot of feedback, both from users and from the GraalVM team, telling us that, you know what, like your approach leads to like the smallest binary, the fastest binary, but it's not optimal for code that you don't know about, right? So for code that you write, for example, let's say you have your own library that for whatever reason, like in a static init, like starts a thread or does a thread local random or secure random or whatever, that will cause problems in when you're building the native image. So the more pragmatic approach that we're considering and will probably adopt at some point is like all the code that you write as an application will continue to be it will not be statically initialized at build time. It will just, the static initializer will run at runtime just as it does with JVM, right? So that's something that like we took like the approach that we're going to make it as good as possible, but it's not the most pragmatic approach for all cases, right?
Dev mode. Well, I think that's one of the most the nicest feature of Quarkus, because it really makes developers' life, nice, and it's really a joy. You start in the background. It's independent of IDE. You can use it with VI, and it just works. Like for the grand majority of projects, it just works. It knows what you do. It knows how to reload the app when there are changes. It lets you do continuous testing, and it's really, the Quarkus architecture helps to establish this, and one thing led to another, and all the nice features now you have with Dev UI, because we know exactly what you're doing. We can even apply heuristics and figure out, like, you have an endpoint here, and you marked it as blocking, but it doesn't do anything blocking. So maybe it will be more better to mark it as non-blocking function. So we can do a lot of that. And now it starts paying off now with all the AI capabilities. We will talk more about it later.
We'll briefly touch on that.
Maybe you want.
Yeah, but the problem is, okay, so for folks that consume Quarkus, like, this feature is amazing. Like, dev mode is amazing, because as you write your application, you don't have to configure anything. Live reload just works 99% of the time, and you're all good, right? But for us who develop Quarkus, this is like a huge source of complexity, right? And the complexity essentially comes from the fact that we need multiple different class loaders. Now, nobody in the Java, except maybe for like 2 or 3 people, nobody in the Java world likes class loaders or wants to work with them. But we're forced to, because we, like, the dev mode, like Dimitris said, is such a mind-blowing experience. But it also comes with, like, a source. It becomes a rare source of bugs in cases where, like, somebody says, I have this Spring Boot application. It uses this specific library that, like, we've never seen before. It uses this library, and it works fine on Spring Boot. But I migrated my application to Quarkus. It works good, except for this, right? Then when I do live reload, like, nothing works. And you know what? It's your fault, because in Spring it works, and at Quarkus it doesn't. And then that makes sense, right? From a consumer point of view, that makes sense. Because for them, the only thing that changes is Spring Boot to Quarkus. But in reality, almost 99.99% of the cases we've seen where this specific thing happens, it's that the library is doing something that is fundamentally wrong in the proper JVM context, right? So in the JVM, a class is not identified by simply its name, right? So we've seen libraries that, like, cache a class by its name, which is totally wrong, because in the JVM, a class is identified by its class loader and its name, right? So when you have a library that says, no, for this name, I'm not going to do class 4 name, I'm just going to take it from the cache. That's totally wrong, and it will blow up the application after your first live reload. So we've had to fix a lot of those kinds of issues. There are all the other worse issues for us in our CI. Sometimes we get out of memory errors, and it's not the out of memory errors that most of people are used to in Java. So most people who see these just have a memory leak, which is like you're not closing something like a file, you've opened it 100 times, blah, blah, blah. They're fairly easy to identify with the proper tooling. What we see is class loader leaks, right? So anytime a class loader is leaked, like, you essentially, the class loader keeps, it can't be closed by the JVM because there's some reference to it somewhere, like in some thread is holding on to it. Then that leads, after you reload like 10 times, then that will consume all the meta space of the JVM and it'll just blow up, right? So again, great for users, pain for us.
Yeah. And when it comes to APIs, one excellent choice for Quarkus was we based it on Vertex, which uses NetE for all I/O basically, and Vertex is like the best toolkit there is for asynchronous I/O, which gives in Quarkus it's reactive core. And all the options for us to build on top of that. So we have the reactive core, but on top of that, we can offer a blocking layer for your apps. So your apps, without knowing, they have a very efficient layer underneath using the familiar programming models. You can also use those reactive APIs if you want. if you want to be super lean and fast. And Vertex is like kind of a standard in the community. It adopts all the latest things. We get them for free. And it also explains like why Quarkus normally tops the benchmarks everywhere, when not only for memory consumption and startup speed, but throughput.
Throughput, yeah.
And that's the reason. And for us, this is also enablement factor for virtual threads.
Yeah.
We can build on top of that. It's not like against either or. It's both. It works on top of that.
But
yeah.
So that's a great choice for consumers. But again, for us, it's hard, right? So for, let's say now we're in the process of moving from Vertex 4 to Vertex 5, and Vertex 5 is based on NetE 4.2, and it has a lot of changes. That means like for us is like a multi-month process of moving all extensions that do IO with Vertex from Vertex 4 to Vertex 5. So users basically, like when we release Quarkus 4, very likely you'll see very little changes in this front, but under the hood, like we've done a lot of technical work and a lot of coordination work to make it happen.
Now, the other thing is like, okay, what APIs we support? Us coming from the Java space, Java E space, we liked standards, but standards present us with a problem. They moved slowly and at the same time altogether. And on the other side, we had the Spring Boot, the Spring crowd, where they could just use whatever they want and pick whatever they want and rename whatever they want at any given time. So it was like an unfair fight. To us, it looked like you're fighting with your hand tied behind your back, right? So in Quarkus, we adopted a more pragmatic approach where we just we pick and choose whatever people want. We support a lot of the standard stuff, a lot of the microprofile stuff, de facto standards, new APIs, even a dozen of Spring APIs. Everything is possible in Quarkus, and you can pick and choose what you want, and it seems like the right choice for now.
It is, yes. But let's talk about some things that were good and not good in this API space. So Dimitris and I were both at Devoxx Belgium, I think in 2020, probably, right? And there was some person that who's one of the first that talks that we had seen that was comparing like Spring with Quarkus. And he had like different points, like who does like REST better, who does messaging better, blah, blah. One of the points was who does persistence better, right? And what we saw was like people preferred Spring Data JPA versus what Quarkus did with Panache, like 85% to 15%, right? That meant that Panache wasn't like a bad implementation. On the contrary, it was very good. The problem was that it felt too foreign to people that were used to the Spring Data JPA way of doing things. So the point here is that like you can have great ideas, you can push the boundaries, but there's a limit to how far away you can go from the current status quo without people being alienated about what you're trying to do. So now we have the original Panache, which was like half active record and half repository based. Now we have a new Panache Next, we're calling it for the time being, Panache Next, that utilizes Jakarta data, which you can think of like as a better Spring Data. But now it's like a lot more familiar to people who are coming from the Spring Data JPA world. And it uses something that is amazing under the hood, but almost nobody knows about, which is Hibernate stateless session. We don't have a ton of time to talk about it, but essentially it means that Hibernate doesn't have a persistence context where like the entity is tracked everywhere it goes. It's essentially you get like fire and forget type semantics to the database, right? So we had an initial approach. We've iterated it on after like 5 years of seeing like what the initial pain was. Now observability. Now this I wouldn't say we've made a mistake, but we've been forced. We've been forced to track what the whole ecosystem has been doing in this space, right? This space, like remember, like cloud native came out, I don't know, let's say 2014, 2015. One of the big things back then was like you have microservices, so you have to observe everything you're doing. right? But there were there were very competing standards to how things were done. And this, I think there was like no standard for metrics, and then but there was a standard like for tracing, like open tracing, and then it became like something else. And now you have like open telemetry. So we've had to move from one to the next for, let's say, no huge value to users, because users just want to say like, oh yeah, I want to have these metrics and I just want tracing working everywhere, and I don't want the API to change every 1 or 2 years, whatever. But that's the cost of having to keep up with what the de facto standards are in this world versus like for the old Java E world where everything was like super stable, right? Didn't change fast enough, but it was super stable. For JSON, we started with the approach, like we had people on the team that were like, no, let's not do Jackson. Let's do JSON-B because that's the standard. And like, that's what Java E world's all about. We started that, but it was like very not on didn't have feature parity with Jackson, and everybody in the community was like, no, Jackson's like the de facto standard. You have to do Jackson. Everybody's doing Jackson. Everybody in Spring is doing Jackson. So we moved away from like recommending JSON-B to Jackson. Now that has been a good decision for sure. But for example, now with Jackson 3, again, we have to do a bunch of work to move from Jackson 2 to Jackson 3 without causing a huge pain to users, and without we don't want to end up in a situation where all the optimizations Dimitris talked about, where we're trying to like limit the number of classes. We take those away and allow, like, we have a situation where we have Jackson 2 and Jackson 3, and suddenly your application is like loading like 3,000 more classes and taking like half a second more to load for no good reason, right?
Community. I think we got it pretty good in this regard. We have tons of contributors that are helping us, make Quarkus. And you can think of it, for every core developer on Quarkus, there are like more than 20 contributors helping out. So that's a huge leverage for the project that explains, its success and its moving forward so fast and with so much innovation. Of course, to contribute to core Quarkus, it's hard. You need to learn a lot and set up a lot of stuff to get your first contributions in. It's easier for the extension ecosystem because it's much smaller. We celebrated our 1,000th contributor. It's months before.
Yeah, probably a year ago. I don't know.
So now we're more like
now it's 1,180 plus when I checked a few days ago. Yeah.
So and it keeps growing. So that makes us pretty proud and very, very responsible also.
And we're actually making this easier for people because now we are in this like AI world, right? We are writing down skills and like instructions for agents to say like these are the practices you need to know when you're developing for Quarkus, and that'll definitely make it easier for people to say, like, instead of having to learn like a huge number of things up front before doing anything in core Quarkus, they'll find it a lot easier.
And if you contribute to Quarkus, you get one of those cool t-shirts.
So we have 1, 2, 3, but
for the major versions,
Quarkus 4 will probably be released sometime this year. So get your contributions in now, and then you'll be able to get a Quarkus 4 t-shirt.
And you can't imagine like the logistics for shipping t-shirts in 30 different countries, including Guatemala and stuff like that. So. Maybe.
Yeah, so with such a large project, right, we like I said, we knew a lot of Maven. We obviously had experience with CI and all that, but we had a lot of help from people that did very cool work, to be honest, right? So, for example, we have the GitHub incremental builder Maven plugin, which is super cool because it allows Maven to only run modules that have been changed by the branch that you're looking on versus main, and that is very important for Quarkus, because in Quarkus, like if you do like a full CI run, like with like Java 17, 21, 25, and all the modules, it probably takes over 3 hours, right? So when somebody's contributing something small, we don't want to have to run like everything. We only want to be able to run things that are affected by that change. And like this GitHub Gitflow incremental builder allows us that. That's super cool.
By the way, a full CI run for our previous project, Jabos, on the press application server took 2 weeks.
2 weeks, okay. So yeah, it's a whole different scale.
Yes.
And then because we're an open source project, GitHub gave us like extra runners, which is very good. We have, like I said, people from Maven, Tomas has mentioned here, who have been very helpful, like looking at Quarkus, looking at the pain points of Quarkus and Maven specifically, and then developing solutions to make the Quarkus build better. Gradle, again, like I said, has helped us a lot with the Gradle stuff. We have the runs on thing, which improves our CI with dedicated runners from AWS, and a lot of help and interactions with people from Open Rewrite because they are very interested. Like they have clients who want to move from like Spring Boot to Quarkus, so we collaborate a lot on that kind of thing too, right?
Now about being open. Well, in Quarkus we are super open, and we proved it by moving the project to the Common House Foundation. So neither Red Hat nor IBM nor anybody else owns the intellectual property behind Quarkus, which guarantees that the project will remain open forever, basically. And we try to do that like in the day-to-day work. So we have now every other week there is a public community meeting where everybody can contribute and join in and listen from the core developers or yourself if you want to discuss anything. Design decisions are public now. We have architecture decision records. Yes. We have working groups, many for different topics. So, go to GitHub, you might find something that's interesting to you.
And we should say here, in the spirit of like criticizing what we've done, like the code has always been open source, right? From day one, it was open source, and that was the easy part. The hard part, as Dimitris was talking about, is that to get to make like our workflow more open to people who are not like part on the payroll of, let's say, Red Hat or IBM to be able to contribute, right? Like the design decisions or team meetings, all that stuff was initially not open. So your only way of like interacting would be like GitHub and chat, right? But now with everything being open, it's much easier for either individuals or companies that are interested and working on Quarkus to be part of like the whole experience, right?
And in Quarkus we release very often.
What were you saying yesterday?
The first year of Quarkus we released on average every 9 days, like a feature release, right? And at some point we slowed down. Now we release every month a feature release. And anytime when there's a CVE or so our release mechanism is pretty efficient. We're really agile, and it was funny. At some point our company was having initiative to become agile, and when they came to us, I said, "Okay, what else do you want? Like,
how much faster?"
They're asking us to go slower. So
yeah, like customers, customers wanted slower. They didn't want faster. Right?
Yeah, right. So what else were here?
So we didn't initially have an LTS. We were like rolling all the time. After a while, we realized that people like enterprises need more stability. So we introduced LTS, which we release every 6 months, and we support for 12 and maybe even more for extended support, right?
And for commercial support, now there are 2 offerings. There's the Red Hat build of Quarkus and the IBM build of Quarkus. So if somehow your company wants professional support, it's there.
Yeah, so with all that releasing so fast, you needed automation, right? And we didn't initially have it. So initially, like there were some like handwritten bash scripts that somebody would use every few days, go and try to release and like spend half their day like babysitting the release. What we did was incrementally build towards automation, because Quarkus was very big, but there were also different pieces that also need to be updated when they were released. So we eventually moved towards full automation, where we have our own GitHub bot. We have our own GitHub actions, so we dog food everything. We write it ourselves, and this is also super important in a world where supply chain attacks are becoming more and more prevalent. Like we have a strict policy now of like no actions, no like random GitHub actions, because those can do anything to your CI, steal any credentials you might have. So we write all of this ourselves with our own framework. and it's been very good. So Ecosystem CI is part of the automation initiative that we were talking about earlier with Quarkus. You have a platform where all the extensions are, but you also need to know that these extensions work with like each new version of Quarkus. And this is what Ecosystem CI gives you. It gives you a way for all extensions that are part of the Quarkus to know which versions of Quarkus they build against, and to be able to build against main, so extension authors are aware of like what potential problems might come.
Maybe we should just
We skip this.
run a bit.
Yeah.
Marketing, yeah, okay, we're not too good at marketing, I guess, but we try to fix this. I'll run through because
too much reactive, too much.
Yeah, and the fact is that Quarkus is good for everything. We market it as cloud native framework for Kubernetes, but you can build all sorts of stuff around Java. Monoliths, CRUD, EDA, CLIs, AI infused, Kubernetes operators, batch jobs.
And I think we didn't even realize this ourselves, how good it was at writing everything in the beginning, right? Yeah. But now, we
and we learned this from our users in our community. And for AI, we do a ton of work. In the workshop, like 2 days ago, we showed. Yesterday, we showed a lot of stuff, but there is a lot of stuff coming as well, which it's in the works. So
so we're just going to say like we jumped on the AI train like very early for the Java space, like 2.5 years ago at Devoxx Belgium with LangChain for J. Then we created an extension that's like the most popular Quarkus extension now at this point. Last year, let's move ahead. Last year with Quarkus with MCP, when MCP was released, we immediately jumped on that, created the Quarkus MCP,
which is the fastest MCP server out there, minus like the Rust one was
first.
Like very close to the Rust one.
So easy to use, right? It's so easy to write a MCP server in Quarkus. So we do all that. Now that we have this very cool initiative called DevStar, which essentially we're going to turn Quarkus into like a platform that provides a whole lot of context to AI. So you'll be able to use your AI assistants to like do dramatically cool stuff with dramatically little effort, right?
So
this is very much ongoing. We'll have to present this as demo. Yeah.
Absolutely. Or join the Quarkus calls, the community calls, and you learn more about it. So, in conclusion, how did it go?
Yeah, so the initial ideas were great. Like some of the individual choices were not. The good thing is that there's a lot of enthusiasm, a lot of excitement that essentially led to disparate ideas that we're now like trying to make more harmonized better.
Yeah,
right?
and the Quarkus platform has matured. It's everywhere now, and the cool thing is that it keeps evolving. There are still a lot of things to do. We still have many ideas.
Yeah, there's a ton of stuff to do. So anyone who wants to be involved, there's still a ton of work to do.
Yeah, and it can happen either in the extension ecosystem. And the cool thing there is anytime you optimize an extension, you benefit everyone using it. They just have to recompile. And it's transparent to them. And in terms of developer experience, I think we're gonna see more in the works.
Yeah, absolutely. So everything like across the board, right?
I think we're out of time.
Yeah, we're out of time. So thank you very much for joining us at this difficult hour.
Thanks for making it to the end.
Thank you.